This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will test the Plan B variable positive power supply. I'm going to use the prototyping systems enclosure to test the Plan B positive power supply. The output of the rectifier filter board is connected to the first two binding posts. Let's position the board on some Velcro loops. Now connect a negative input to the power supply to the negative out of the rectifier filter board, and also connected to the common of the multimeter. The positive input power is connected to the binding post. It's now got an alligator clip attached to it. And the red lead coming out of the multimeter is connected to the positive output of the Plan B variable positive power supply. And we'll connect positive input, turn the power on. And we got 21 plus. Making some adjustment. I just want to see if the variable positive power supply is in fact variable. Now at 6.36 volts. That's all the way to the end of the scale. How low can I go here? It should be very close to zero, but it's only 0.490 volts. It's not great, but it's good enough for me. It meets my requirements. That's 4.87. Just to adjust it up a little bit. 5.91. Going up a little bit. 5 volts is a standard voltage I would want. 12.21. Good. Adjusting it further upwards. I was trying for 15, but the adjustment is very sensitive, and it's slow going from low to high. Takes some time to settle. All right, now I'm at the maximum or close to the maximum. Here you go at the maximum of 22.484950. 22.5253. Adjusting it downwards again. It's a little faster to settle when it's adjusting downwards. 17.6. Towards the middle, my 15-volt op-amp standard voltage of 15.16. Well, I was going for 15.00. It's a very delicate adjustment, and it's only a small portion of the pot range. Now I'm back to the minimum? What the? I don't know. This is 3.562. That's not good. Back to the maximum. Maximum is now 25 points. It's bouncing. 25.78. Just during the period of this test, the maximum is changed and the minimum is changed, and they are 3 volts over what they were just minutes ago. It's kind of erratic. Is anything heated up here? Is there a piece of wire or crud stuck in here? This is the next day. I did some more testing on the same board and the same hookup. Really, nothing's changed. I just turned the power on. And here now the new minimum is 1.383. This is erratic. It changes within the space of 10 or 15 minutes the last time. Today, the new minimum is different from the minimum it was yesterday, which was about 0.48, 0.49. And this is definitely as low as I can get on this. Now I'm checking the voltage across the potentiometer that's hooked into the set resistor, and the voltage is linear and it adjusts down to zero. That set pin should be what the integrated circuit is following. The output should follow this resistor. And if the resistor says 13, I know that's what should be output. If the resistor says 0, it should be producing as close to 0 as is possible, but it's not behaving that way. The maximum on this output of the set resistor, the voltage, is 25. Oops. What have I got at the output? 26.35. At this point, I'm measuring the output of the power supply. It's just too erratic to be useful. And the adjustment isn't full range for the pot. Okay, the next day, I've decided to at least fix one problem that I can. I'm going to get rid of the 1 microfarad capacitor across the set pin, and maybe the low to high adjustment will be a little quicker, take less time to settle. As for the other stuff, I don't know. It's got me. The maximum here today is 25.4. I've got a 1K resistor effectively across the output of this. Okay, here's today's low voltage is 1.396. Going up, the response is much quicker. The maximum is 25. So that's fairly consistent with the last test. Now, what I'm testing is this pin. I've just taken out the 1 microfarad capacitor from across the set potentiometer, which is 2.5 megohms. And the new low voltage is essentially the same as last time, 1.4, 1.39. I'm shorting the set resistor, the set potentiometer, to make sure it is in fact grounded, and I still get 1398. What else can I do? I'll take the output ground, and I'm going to attach that ground to the set pin directly, bypassing the strip board, and I'm still getting 1.39. It's not the circuitry. What the set pin sees is supposed to be output by this chip, and it's not happening. So, I don't know. I think the next thing to do is simplify and just create the simplest version of this chip that I can. And it's still an adjustable regulator, although I'm not sure it's actually regulating, but it just doesn't go down low enough for my purposes. Here's a bare bones version of this circuit where I have the LT3080, the required output capacitor, and an adjustable potentiometer to establish the voltage. What I got is a maximum voltage of 27.76. It's going up in the world. Used to be 25 point something, used to be 21 point something. And And the minimum is now 1.87. I don't see how this could go wrong. There's just three components: the chip, a capacitor, and a variable resistor. Now the minimum is 1.9. Well, you know, changes minute to minute. Maximum voltage I can obtain with this potentiometer set to its maximum setting is now 27.86, which is quite close to the input voltage from the rectifier filter board. The minimum goes to 1.9. Okay. I don't know what else I can do here. Let's see if we can do anything to further debug this. Let's reconnect it to ground, make sure the connections are solid. Alright. I mean, look at this. This is what can go wrong with this? Now, I've got the multimeter hooked up directly to the tab of the IC, so it's not to get involved in, is there something wrong with the strips, or are there solder bridges, or is there's some sort of break in the strip? Well, it's not. I'm directly connected to the tab. Again, the minimal voltage I can get out of it today is 1.9. I'm going to ground out, short out the set resistor. One end is ground, the other end is now also ground. The output should be close to zero as the chip can come, but instead it's 1.978. No good for my purposes, sorry. Back to the drawing boards. In this video, I tested the Plan B variable positive power supply using a variety of voltage adjustment potentiometer positions. Initially, the results were useful, but subsequent testing yielded erratic results. I modified the circuit to improve response to upward potentiometer adjustments. I grounded the voltage adjustment potentiometer, then the set pin, trying to get near zero output, but still got erratic results. I constructed a stripped-down version of the circuit, but still got erratic results, yielding output that was approximately 3 volts higher than should be. The chip did not seem to comply with its spec sheet. I'm going to suspend video production for the next few weeks while I come up with a dependable variable positive power supply that meets or exceeds my original requirements. It shouldn't be this difficult. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.